Right. So good morning, everyone. So today I'll be discussing about classification of fermentation systems. Okay. So in the first session, I'll be giving an overview about bioreactor. What is a bioreactor? What are the components of a bioreactor? And our next session, I'm going to discuss about classification based on mode of operation as well as classification based on sizes of the bioreactor. Right. So, so if you have a look at this picture, this is the schematic representation of a bioreactor, right? So you have a core vessel in which we are going to grow the microorganisms inside the vessel using a media and maintaining appropriate environmental conditions for nurturing the organisms and produce the products inside the bioreactor, right? So you would have seen such kind of pictures in your earlier courses like your biochemical reaction engineering or any other chemical engineering subject, right? So if you have a look at this picture, schematic representation carefully, what we have is a vessel which is either made up of steel or glass. Most of the industrial as well as laboratory vessels are made up of either stainless steel or glass. In case of very old systems, we still see the having possibility of having a concrete vessels, very old systems. But right now, most of the industries have steel vessels or the glass coated vessels. So if you see the picture, we have an impeller in the middle which helps in the agitation of the components or mixing of the media, and we have a sparging system which helps in sending the air or oxygen required for nourishment of the microorganisms that we are growing, and we have taken a liquid media here, right? So this is called submerged fermentation, where we are going to take a liquid form of a media and inoculate the media with suitable microorganisms and produce a desirable product inside the bioreactor. And if you see the blue lining, that is nothing but the jacket, which is called cooling jacket, where cooling water will be circulated throughout the vessel, and the vessel will be cooled down, and the temperature that is increased during the process of bioreactions will be taken off with the help of this cooling jacket. And we have the top coat where we have several accessories connected to the top coat. We have majorly a pH probe, we have a dissolved oxygen probe, and we have some other accessories to measure the growth rate of microorganisms during the process of growth. So we have a motor which is connected to the shaft. This motor helps in rotating the impeller and give appropriate RPM required for mixing of the content inside the reactor. So what you see here in this picture is nothing but a Rushton turbine type of axial impeller which helps in mixing, right? So I'm coming here. So this is a classification based on size of the bioreactor, right? So this is the schematic representation of a bioreactor, and all the bioreactors, whether you take a laboratory scale or a pilot scale or an industrial scale, you take whatever the bioreactor, they look exactly the same. They should look exactly the same. The configuration should be exactly the same. Only thing that varies is the size of the bioreactor. Okay. So based on the sizes, we can classify these bioreactors into a small scale bioreactor, which generally uses 1 to 5 liters of broth to produce the product. And the second category is pilot scale bioreactor, which can accommodate around 20 to 100 liters of broth for producing products. That means little larger than the laboratory scale. And the third scale is the large scale bioreactor, also called as industrial scale, where we are going to produce lots of product using such kind of bioreactors in the industries. Okay, so this is about an overview about bioreactors. In the next session, I'll discuss about classification of bioreactors based on mode of operation. Thank you.